So shall we start? Say yes, no. Are you ready?
Yes, sir.
Yes, sir.
Yes.
Great. Okay. So there are big topics, 7 topics, which I will try to cover. The first thing I'll talk about. So the overall topic is spectrum related aspect. All the aspect related to spectrum I'll be talking about for 5G new radio. 5G radio, we call it new radio, NR. So what are the different frequency band which is supported by 5G? Then I'll talk about channel bandwidth supported in 5G new radio. And what kind of waveform, what kind of modulation is used? Then what is the concept of numerologies in 5G? There's a concept of subcarrier spacing, resource block. Then we will talk about what are different relations between numerology, bandwidth, frequency band, cell size, and so on. And then little bit about carrier aggregation and bandwidth part. So these are the 7 topics which I will try to cover in next 1 hour. And I mean, we will be interacting kind of with each other. I'll be asking certain questions. The first topic which I'll try to cover is the frequency band supported. So before I actually start, let me ask many of you in BSNL. So if you talk about 2G, so what was the band supported in 2G? Which band we used in 2G?
900
and 1800.
900 megahertz, 1800 megahertz, right? And 3G. So, and in this also we had how much bandwidth? Do you recall?
6.2 and 3.8.
6.2 megahertz, right? Okay. And 3G, how much? Which?
2100.
2100 megahertz.
5 megahertz.
And 4G? Anyone? BSNL?
2300 megahertz.
2300, sir.
Megahertz, right? So these were different bands which we were already using for 2G, 3G, and 4G. And almost the entire availability of the bands are already consumed, right? So what will happen to 5G? We cannot straight away use this frequency band unless we reform close 2G, 3G, 4G. These frequencies at least cannot be used. Okay, so these frequencies which are less than 1 gigahertz, which we talked about 900 megahertz and other bands like 700 megahertz band, 600 megahertz band, 400 megahertz band, those are less than 1 gigahertz and we call it low band. And in these bands, we already have 2G, 3G, and 4G. And 5G will also, may I request that some of you have kind of opened your mic, kindly mute yourself unless you are looking to talk to. Okay, I'm just muting all of you.
Kindly unmute, sir.
Okay.
So you have got muted, so please unmute.
So can you hear me now?
Yes, sir.
Okay. What I would request that some of you are also having opened your mic, so kindly mute yourself unless you want to talk to. So the low band, which is less than 1 gigahertz, 2G, 3G and 4G are also deployed onto these frequency, and 5G also supports that. But since availability of this spectrum would not be there because we already have 2G, 3G and 4G, so it's very difficult to use these frequencies for 5G unless we are able to refarm it, close the 2G, 3G and 4G and use those bands for 5G. But 5G supports those bands, or a new lower band like 700 megahertz in India, or other bands are auctioned and those are uh, purchased by the operators. Now we have mid band, lower side of mid band, where we talked about 1800 megahertz band, 2100, 2300 megahertz band. So many of you told that on these bands, even 3G and 4G services are uh, launched. In some case, even 1800 we use for 2G. So primarily it is 3G and 4G. And 5G will also support it, right? So 5G supports even the lower side of mid-band. And some of the mid-band frequency, which is there from 3.5 gigahertz to 7.125 gigahertz, those are vacant today. Those are vacant today, so those bands can be supported by 5G. Some of it are supported by 4G, but 5G will definitely support. If you talk about band N78, which is 3.5 gigahertz, that is called kind of a gold band for 5G because this band is mostly not used by any operator across the globe. So this is becoming one of the favorite band for 5G while being deployed world across because of the availability and also the good property it is in between lower band and millimeter wave. And of course, the high band, which is from 24 gigahertz to 52 gigahertz as defined by 3GPP. So there we can launch 5G services on those millimeter wave. So what we see here is that the earlier technology were using certain bands, either low band or mid band or low and mid band, whereas 5G supports low band, mid band, and also the higher band in millimeter wave. So that is frequency band support. So let me tell you that how these frequencies are. Lalit had asked this question day before yesterday, that how these frequencies are decided, which frequencies or which band to be used for which technology. So first of all, identification or earmarking of frequency band for mobile is done by ITU, rather ITU-R sector, right? And since countries are member countries, so accordingly countries also allocate the designated bands to their telecom service provider. Although they are not bound by ITU regulations, but generally they allocate. If they will not allocate the same plan which is decided by ITU radio regulation, then what problem will come that when you go for roaming, your mobile may not work. You will not get economy of scale. Your devices or the BTSs in your market may be costlier if you're not following ITU radio regulations. So it is important for development of ecosystem, economy of scale, and also you have interoperability across the globe. So once those frequencies are earmarked by ITU, 3GPP is a kind of a standard making organization for mobile as of today, specifies particular band for a particular technology. For example, for 4G, they had decided that these are the band which will be supported. And for 5G also, they have given certain band. Now let us talk about what are the additional frequency band earmarked by ITU-R. Every World Radio conference, which is held every 4 years, where all the member countries, there are 180 plus member country of ITU, they participate and they decide which are different frequencies which will be used for mobile communication and also for satellite. So the last WRC was held in October to November 19, wherein 5G bands were identified, right? So these were the bands. You see that these bands are in millimeter wave, 24 gigahertz, 37 gigahertz, 45 gigahertz, right? 47 gigahertz and 66 gigahertz. If you calculate total of it, total bandwidth, it is 17.25 gigahertz. Additional bandwidth in different bands were earmark. Take my word, it is earmarking only, right? And do you know that how much spectrum was earlier allocated for mobile communication? It was just 1.9 gigahertz. It was just 1.9 gigahertz. This figure, right? This was the only allocation. So how many times additional spectrum was earmarked during WRC 19? Can you calculate? Is it 8 times? So just see that since 5G would require, as we had calculated in the first session, 700 megahertz, 800 megahertz by each operator in every LSA. So that's why earmarking of millimeter wave was done in the WRC so that sufficient spectrum is available across the globe for 5G. Just see this. What I'm trying to show here is that what are the additional bands in addition to whatever band are already available for 2G, 3G and 4G were allocated for 5G by 3GPP. So there are two ranges, we call it frequency range 1, which is from 410 megahertz to 7.125 gigahertz. The other is the FR2 frequency range 2, which is from 24 gigahertz to 52 gigahertz. So within these range, certain number of bands are decided by 3GPP for 5G during release 15 and 16. This covers up to release 16. Release 17, some additional bands are also earmarked. So just see, this is N78. That is a nomenclature which is from 3.3 to 3.8 gigahertz. N77 is from 4.2 gigahertz. N79 is 4.4 to 5 gigahertz, right? So these three additional bands in FR1 and these four additional bands in FR2 is kind of specified by 3GPP in their standard release 15 and 16. So that means 5G will operate not only on the bands where your 2G, 3G, 4G operate, but also on these three bands. So this is your mid band, the new frequency band, because it was earlier not used by any mobile communications. These are also millimeter wave in FR2 range. So let me ask you why we call it millimeter wave. Can somebody answer?
Wavelength in the range of millimeters.
Right, sir. Very right, sir. The wavelength of these frequencies, if you just inverse these frequency band, you'll get the wavelength which will be there in the millimeter size. So this is complete list. I'll try to spend some time here on this particular chart. I hope it is visible to all of you. Those who are using mobile may not be able to see. Those who are using desktop laptop will be able to see it definitely. Just see the nomenclature. So the nomenclature is N1, N is for kind of new radio, N1, N2, N3, N5, N7. These are different frequency band which were already there for 2G, 3G. I mean for 4G the name was B1, B2, B3 and same range was there. And what you see that here these bands are from up to this place, these are FDD band. What is FDD? Can somebody tell me?
Frequency division multiplexing.
division
Duplex.
Division
Frequency duplexing.
is different from downlink frequency.
Yeah,
Uplink
so you
frequency
have
range is different from downlink frequency range.
very
Some
right, very right.
basic frequency spacing is in between the uplink and downlink frequency.
Very right. So if you see this frequency N1, N2, N3 and all, you have some chunk of frequency in, see this, uplink side. This is your uplink and this is your downlink frequency. And of course, there will be some gap in between. So uplink and downlink frequencies are separate. That means separate transmission for uplink, separate transmission for downlink, separate band or frequency band for downlink. Now the bands here are TDD. That is your N34, N38, N39. These all bands are already defined as FDD and these were also available for 4G. So what is TDD?
Time division duplex.
Sir,
Okay.
operation on time frames.
Yeah.
Operation on time frames.
Look at the frequency here.
Sir,
2010 to 2025. The same frequency band is for uplink and downlink both. So that means some time is given for uplink, some time is given for downlinks. That's why we call it time division duplexing. Again, some bands, that is N66, N70, N71, N74, these bands are again FDD and these were also available for 4G. Right now there is some new term N76 and N77 which is being called SDL. What is SDL?
Supplementary downlink, sir.
Right. In case of 5G, you can have additional spectrum in uplink and also downlink. If you have it in downlink, we call it supplementary downlink, right? Now let's look at these frequencies. N78, N79, right? And N70, 80. Up to here, let us see N79. These are TDD band. Just see. These are TDD band and these are new band. This was not there for 4G. This was not available for 4G. These are new band where N78 and N79 is there and these are only TDD, defined as TDD. And now there are certain bands which are SUL. What is SUL?
Supplementary uplink, sir.
There are many
Same as
bands for supplementary uplink. What can be the reason for having more number of supplementary uplink? Can somebody guess? Try
for
to answer
additional
this.
capacity, sir. For providing additional capacity for the band.
But why in uplink only? Why downlink very less, uplink many bands?
High requirement of upload data. Upload data may be very, very high because they are the source of that.
Okay, any more answer? So actually, if you look at the characteristic of coverage, so coverage because of the uplink, because your mobile, so your base station you can pump 40 watt power, 60 watt power, but from your mobile you can pump only 2 watt power, right? So with higher frequency, suppose a higher frequency transmission, millimeter wave or mid-band is going on. So in downlink direction, you may be covering a larger area, but in uplink direction, your coverage would be less. And because of the uplink, your overall coverage is less, right? So the concept, what concept 5G is trying to use, that for uplink, I may use a lower frequency band. Just see, these are all lower one, 800, 700, 1700. These all supplementary are in either low band or mid band, right? So the purpose is that to enhance the coverage, I'll be using additional lower side of the band for uplink, so that uplink and downlink both are available to the device and have a better coverage even using the mid-band frequency or millimeter wave frequency. Is it clear? Yes, no in chat box, please. Please write something in the chat box whether you understood. Yes or no?
Sir, how to achieve the optimal performance of the millimeter wave when you are using the lower band? That means if you are above going
Sir is
above
saying
24
that.
gigahertz.
Let me explain it again because somebody, yes or no, there are two answers. So suppose there is a 3.5 gigahertz base station, right? So because of the BTS can have more power, more capability, more processing. So I can say cover 3 kilometer example. But since there has to be some uplink data also, in uplink direction, your devices may not be able to pump that much data. So that means for purpose of uplink, your coverage is only 1.5 kilometer and downlink it is 3 kilometer. So practically your coverage is 1.5 kilometer. So how to enhance this coverage? So in case I also deploy second frequency in the lower side only for uplink, your device will have 2 transmitter, 2 receiver kind of, or 4 transmitter, 4 receiver. So in uplink direction, it can use the lower band, which has a higher coverage. In downlink direction, it can get more data on mid band. So in that way, I am able to increase the coverage. That is one of the kind of a use case. Is it clear now? Yes, no, please. If it is clear,
Yes, sir.
then, okay, thank you. And now finally the millimeter wave, the 3 bands which I shown you is here. These all are millimeter wave in TDD mode they have defined. Just see 3GPP has defined these as TDD mode. So these are different bands. Now I want to come to one question before I move to the next slide about the problem of US where because of 5G, some airline were not allowed to fly at that particular of time. Can some of you try to answer that or guess the answer?
See, I know that case, Ashokji, because I had dealt with that when it was reported in papers. First, it was reported from US, where they banned it. I mean, the flights, even Air India flights were banned. So in India, that problem is not there, but in US, that problem is there because although the bands were decided and fixed, what will be for 5G and what will be for the airlines, because airlines use some frequencies which they send downwards, I mean, towards the earth, and they take that reflection and then that is called altimeter. I mean, that frequency altimeter, that is basically to judge what is the height of the flight. So while landing, mainly it is used for maneuvering the flight and controlling the flight actually. So what happened in US that what was their 5G bands were already prescribed and this was slightly away only. So out of band emissions were there in the 5G, and with the out of band emissions it was suspected that it would interfere with the flight altimeter, and if the flight altimeter is interfered, then the whole flight will be under jeopardy. It will be a big problem. So they had to ban it. Now that was same thing was referred in India. There was a lot of hue and cry. People referred to TRAI and so many press conferences were held. And TRAI clarified that such problem is not there in India because that auto band emission also is not near to that altimeter. And so that problem was resolved. So that's what I understand. Thank you.
Okay, anybody else want to answer it? Sir is very right. Any more supplement one can give? Yes, sir. PK Singh sir has also opened. Sir, please go ahead.
Yeah, thank you, Ashok. I think the radio altimeters, they basically use a frequency spectrum which is centered at 4.3 gigahertz. And the bands which we are making use, although it has been indicated that the band doesn't extend to that center frequency, but the frequency spectrum of the radio altimeter gets covered in the 4.2 to gigahertz band, and that was the reason why the 5G frequencies were impacting the radio altimeter being deployed in the normal aeroplanes. So that was probably the reason, and studies is being contemplated in India also, whether this problem really exists for the Indian scenario or not, because we have defined the bands which is available on the screen as 3.3 to 3.8 and up to 4.2 and 4.4 to 5.0 gigahertz, and then the 24 onwards to 40 gigahertz. These are the different bands. That center frequency is not getting covered with our bands, but still study is required. And that is what is the current status as far as India is concerned. Thank you.
Thank you, sir. Thank you, sir. So, so I will, for the benefit of all other participants. So, Jha sir and PK Singh sir have answered rightly. So let me tell you that the aircraft system, they use altimeter. The system is called, I mean, that device is called altimeter. Jha sir has explained what it is. So it uses frequency between 4.2 gigahertz to 4.4 gigahertz. As sir said, 4.3 is the center frequency. So where it is, just see, although these are not being used in 5G, just see this part, whatever falls here is between 4.2 to 4.4. So your altimeter traditionally is working here, right? So in USA, they have actually allocated this N77 to their operators and even N79. And the problem is like the aircraft, many aircraft are kind of an older aircraft, and the altimeter system which they are having, they have out of band transmission, or you can say that the filter which they have is not very precise. So they, I mean, they will get lot of interference from nearby 5G sites because, I mean, and also whatever they transmit could affect the 5G network. So this may, I mean, create problem while landing a aircraft or take off a aircraft which uses the altimeter kind of equipment. So that was the issue in US. So how they solved it today, because now aircrafts are going on. So what they have done is, first thing, what they have created some kind of buffer zone. That's a short-term solution, buffer zone near airline where the 5G operators will not deploy N77 or N79 frequency band. That buffer zone they have. So that's a kind of a short-term solution they have brought in. Parallelly, they are working on that all the aircraft should have the latest altimeter equipment, transmitter and receivers with a good and precise filters so that it doesn't impact, I mean, doesn't have impact from N77 and N79. So that is what sir explained. In India, we are not using N77, but we are using N78, which is again very, very far away. So N78 band will be actually auctioned as part of mid band. So as such in India, this problem is not expected. Now let us talk about Japan. Japan is also using N77 and N79. They also have airport, aircraft, etc. This problem was not reported from Japan, all because their aircraft, they have already have very, very good altimeter with precise filter and all. And as sir has said that in India also, although since this issue has cropped in, some study is going on, but I mean, in a broad sense, this problem will not be there in India. So any supplementary question or shall I proceed?
No supplementary question, Ashok. Only that Boeing was affected. I mean, the Boeing operations whether they were from US or India, from another
No, no,
place.
no, not it was not Boeing, sir. It was any aircraft going to US at that point of time was affected. It was not specific to Boeing, sir. Because
So,
India Boeing flight was stopped, so that became a highlight.
yeah, we knew more about Boeing because a lot
All
of human guy was there.
that came into newspaper, so that became highlight.
Thank you.
But now let us look at the channel bandwidth supported in 5G. What kind of channel bandwidth is supported in 5G? So before we discuss 5G, let us talk about channel bandwidth in our earlier technology, 1G, 2G, 3G, and 4G. And I'll ask this question from you all, that if you have heard about 1G, what kind of channel bandwidth we had? Any guess? In chat box or you can open your mic.
30 kilohertz.
30 kilohertz, very right, sir. 30 kilohertz was channel bandwidth. And what was that in 2G? How much channel bandwidth we had in 2G?
200 kilohertz.
Yeah, 200
kilohertz.
kilohertz. And in 200 kilohertz, we used to have 8 time slots, right? So 8 customer can actually hang on this 200 kilohertz channel. Now in 3G, what was the channel bandwidth?
5 megahertz.
5 megahertz. So from 200 kilohertz, it become a 5 megahertz. But in 2G,
Your voice is not coming.
some operator will have 10, some operator may have more, depending upon the customer base at that point of time used to consider. And in 4G, what is the channel bandwidth supported? Anyone? Any guess? Karan?
So 20 megahertz and but with carrier aggregation 100 megahertz.
Very right. 20 megahertz. Sorry. 20 megahertz. And of course, it has carrier aggregation up to 5 carrier aggregation. So it would have gone to 100 megahertz. Now let us talk about channel bandwidth in 5G. Let me erase this thing. In 5G, we had talked about FR1 and FR2. FR1 are the frequencies from 410 megahertz to 7.125 gigahertz. That is low and mid-band frequency. So here the maximum channel bandwidth supported is 100 megahertz without carrier aggregation. Carrier aggregation we'll talk later. So even if you compare with 4G, where we had only 20 megahertz max 1, so it's a 5-time increase in the FR1 itself. Although 5G will support 5 megahertz, 10 megahertz, 15 megahertz, and so on. Just see these figures. So 5G can support all the channel bandwidth, which is shown here. 5, 10, 15, 20, 50. Maximum is 100 in FR1. In FR2 frequency range are from 24 gigahertz to 52 gigahertz up to release 16. Release 17, they have taken some more. 15 and 16, these were defined. So the maximum here is 400 megahertz. So that's why we say the maximum channel bandwidth supported in 5G is 400 megahertz. But of course, that is in FR2. FR1, it is only 100 megahertz. There are certain other parameters which I'll talk about in subsequent classes. Any question on this slide? Okay, if no more question, then I'll proceed. So the next aspect is what kind of waveform and modulation is used in 5G new radio. So before we talk about these modulations, etc., let us talk about 2G, 3G, 4G, and then come to 5G. So 2G, 3G, and 4G. So 2G, what kind of modulation we were using, or what kind of multiplexing we are using? 2G में what you used to do that whatever bandwidth is given to you, you used to divide into 200 kilohertz chunk. So that becomes frequency division multiplexing, and you had 8 slots, so you are using time division multiplexing. Am I right? In 3G, you have a single 5 megahertz, right? So that we used to have code division, CDMA, code division multiplexing or multiple access. And 4G, can someone guess what is the waveform used in 4G?
OFDM. OFDM.
Orthogonal frequency division multiplexing and multiple access both. Okay, now in 5G, the same orthogonal frequency division is used. Let me erase the ink. Okay, so we use orthogonal frequency division multiplexing in 5G also. Why we call it orthogonal? Can somebody tell me? Why we call it orthogonal? Any answer from any one of you?
90-degree phase shift, sir.
Two adjacent carriers are 90-degree.
Okay. Any more answer?
In this, we are using the parameters.
Are equal in number. 0 and 1 are equal in number.
Okay.
We are using the parameters which are orthogonal. I mean, so many we can bring in this, and they are all independent of each other in the planes. So
okay,
that only orthogonal things can give these independence.
Right. So basically, orthogonal here means, so these are 4 subcarriers you see here. 1, 2, 3, 4. So when there is a peak of this subcarrier, at that point of time, there is null for all other subcarriers. So that means other subcarriers will not interfere, and that's why we call it orthogonal. So what we do, so let me give you one example. That suppose theoretical, very theoretical, I have 5 megahertz of channel bandwidth. And in orthogonal frequency division multiplexing, what we do, we use a smaller size subcarrier. That means the distance between, in terms of frequency, between the two subcarriers, say it is 15 kilohertz. 5G, I'll tell you how much it is. 15 is also there. So 15 kilohertz. So how many subcarrier I can have? 5 megahertz divided by 15 kilohertz. Can somebody tell me how many subcarrier I'll get? Just calculate on your calculator. You can do 5,000 by 15.
334.
Pardon?
334.
3,300.
334. So that means I'll have 334 subcarriers, and on every subcarriers, independent data can be modulated. So that means the serial data you convert into parallel 334 data and transmit simultaneously using this orthogonal frequency division multiplexing. So that way you are able to transmit more data without, I mean, so it has got very, very efficient way of transmitting data in this particular concept. Let me erase and move further. Okay, now let us talk about various modulations. One is the waveform, other is the modulation. So, so the modulation used in 5G up to release 16 is QPSK, 16 QAM, 64 QAM, and 256 QAM. So let me ask, when I use QPSK, how much data I can transmit on one subcarrier, and in a particular time, we call it symbol time. Can somebody tell me? In one symbol time, let us assume this as a 1 millisecond. In 1 millisecond, on one subcarrier of 15 kilohertz, how many bit I can transmit if I'm using QPSK?
2 bits.
So answer is 2 bit. You are right. So you can transmit 2 bit per second per subcarrier. Right? Now suppose you have 16 QAM modulation. So how many bits you can transmit?
4 bits.
So you can double the bit, 4 bit per second per subcarrier you can transmit. So you have doubled the speed and so on if you can calculate, right? So if you go on higher order of modulation, you are getting capability of transmitting more data on the same radio resource, right? But the problem is that if you use higher order of modulation, you require very good signal to demodulate. So your coverage reduces. So what system does that the users who are near to base station will get better speed compared to user who are on the edge of the network. So depending upon where a device or a user is, what is the signal condition, the order of modulation is decided mutually between the device and the base station. Some comparison between a frequency division multiplexing and OFDM. In case of frequency division multiplexing, all of you would be knowing that we divide frequency into chunk of small frequency bands. We also keep some guard band in between. And then we kind of modulate these and transmit the data after multiplexing. In case of OFDMA, these guard bands are not required because of the orthogonal frequencies. So it doesn't need guard band and there are certain other efficiency which we get. Now let us calculate. I would request all of you to do this calculation. Please open your calculator. I am giving you these 3 parameters. I have a 50 megahertz channel bandwidth. 50 megahertz channel bandwidth. I have to reduce this guard band from both sides. From this side, 692.5 kilohertz, and from this side also 692.5 kilohertz. And whatever comes here is called transmission bandwidth. And now you have to calculate how many subcarriers I can get if the subcarrier spacing is 15 kilohertz. So whatever TX bandwidth you get, divide by 15 kilohertz, and you will get number of subcarriers. I request all of you to calculate and tell me number of subcarriers. Yes, Himanshu, your formula is right. I request all others to calculate this. Karan is also right. Please calculate and yourself and write in chat box.
48.617, sir.
That is transmission bandwidth. Now divide by 15 kilohertz. Okay, 3241 is the right answer, which Karan and Sudhanshu and Himanshu has given. Rest, I don't know whether you are able to understand, but these are simple things. Please calculate so that you understand better. So transmission bandwidth 48.617 is right. And number of subcarrier 3241 is also right. So as we know that 5G supports even 50 megahertz, and these were the guard bands. So it will have 3241 subcarriers. And now you can calculate how much data it can carry. Suppose very theoretical and rough. Suppose I have 256 QAM modulation. So how many bit I can do per subcarrier per second? 7 bit?
8.
Because 2 to the power 7 is equal to 256. 7 or 8?
8, sir.
8.
8. Right. So I'll have 8 bit. I can do on the every subcarrier, say per second. So how much it will come? 3241 into 8 bit per second. right? Is there anything else I'm missing? Every second I can transmit only this much bit if I have only 50 megahertz. I'm not talking about other aspects. So I'm just talking about very plain. So this kind of speed you can achieve with 50 megahertz with 3241 carrier and with 256 QAM kind of a modulation. Very rough calculation. There are many other parameters which I'm not considering as of now, just to make you understand. Now, let us understand that QAM thing. So let me ask you, let us first recap the modulation. So what is amplitude modulation? Someone from you? Jha, sir?
Yeah, Ashok, actually, I had one small doubt in the previous calculation.
Okay.
As per my calculation, it was coming out to be 3051 instead of 3241. Because what I did that in the guard band is on both sides, that is 692.5 is on both sides. Okay.
Yes.
So actually the frequencies, the gap between the two frequencies would be double of this. I mean, from both sides you are expecting. So I took that 1385 kilohertz actually. I mean,
no. So I mean, not 1.3. You have to reduce that from the channel bandwidth, not from the subcarrier spacing.
No, subcarrier spacing I am keeping same. Let us say that
spacing you cannot change because of, I mean, that is a requirement. The channel bandwidth, overall channel bandwidth which you have from both sides, you are not reducing that from every subcarrier, sir, because it is orthogonal. It is, I mean, there is no guard band here between the subcarrier. Guard band at the end only, and the start.
Right. So that was my mistake. I got the point. So basically, it is not from all subcarriers, correct?
Yes. So that is the
advantage. It is only for the entire band only once only. I mean, both sides double.
Right.
Okay. Thank you.
Okay. So can somebody tell
one
me?
more doubt, sir?
Yeah, please go ahead.
Sir, 3241 multiplied by 8 you mentioned. So one subcarrier of 15 kilohertz, you said it will carry only 8 bits.
In a second. I'm just taking some.
Right. 8 bit per second, right? So that way it's only around 2.5 kbps. Sorry, 2.5 yes kbps. 24 kbps. 24 kbps is the speed, right?
But what I told you, just a rough one. There are many other aspects which will increase the speed. We'll talk about that. So I was just giving you an idea.
I mean, even roughly speaking, 50 megahertz channel bandwidth, a throughput of only 24 kbps seems very low. So what I'm trying to doubt is actually like when you say subcarrier, one subcarrier of 15 kilohertz can carry only 8 kbps. This is where I'm doubting.
So other aspect I'll tell you. I just said in 1 millisecond, whereas I'll tell you.
I think we have to. I feel we have to multiply by 256 also because we are using 256 plan.
I'll just tell you. Since you have raised this question, in 1 millisecond, I'm talking about 4G. In 1 millisecond, there are 7 symbols. I'm talking about 4G now. There are 7 symbols, right? In 1 millisecond, there are 7 symbols. Means whatever your answer you got, actually you have to multiply it by 7 if you're using 4G LTE, right? In case of 5G, it is 14 symbols, right? So you have to multiply again by 14. Not only that, in 5G, what you have, this time slot which I talk about 1 millisecond, you also have half millisecond, 1/4 millisecond. In every such time slot, you have 14 symbols. So you will achieve the rate which 5G has envisioned. I gave this calculation to you just to understand. For the
So okay, I understand. I think the confusion is when you say 8 bits per second, it's not per second, it's per millisecond actually, right?
Yes.
It is 8 bit per millisecond, not second. Okay, so I understood wrongly.
Not only millisecond. Within the millisecond, there will be 7 symbol in case of 4G, 14 symbol in case of 5G. Not only that.
I got the point, sir. I got the point.
Not the point. I just gave you calculation that how to calculate the data. Right? I said there are many other parameters which we'll talk about.
Sure.
Okay, so
yes, sir. Yes, fine.
to make you understand the concept, I told you that assume 1 millisecond or 1 second. Okay, so can somebody tell me about amplitude, frequency, and phase modulation? Just very quickly.
Sir, in amplitude modulation, the amplitude of the carrier gets changed due to according to the instantaneous amplitude of the modulating signal.
Very right. And frequency?
And in frequency modulation, the frequency of the carrier changes according to the instantaneous amplitude of the modulating signal.
Very nice. And phase?
And in phase modulation, the phase difference of the this carrier gets changed as per the instantaneous amplitude of the modulating signal.
Very nice. And what is the combination of amplitude and phase? You change phase also and also the amplitude. So the QAM modulation is nothing but using the phases, I mean different phases. So for example, if we are talking about QPSK, there are 4 sets of phase and amplitude. 1, 2, 3, 4. There are 4 states. For example, यहाँ पे ये phase है जो भी डिग्री है 45 डिग्री, यहाँ पे आपका 90 डिग्री आ गया 270 and so on. So basically you are changing the phase. So you have 4 states. So that means you can transmit on a one subcarriers 2 bit of data. 2 bit can represent 4 numbers, no 0, 0, 0, 1, 1, 1 and 1, 0. So if you have QPSK, which is also called 4 QAM, you can transmit 2 bit of data on a subcarrier for a symbol duration. So it's, I'm not talking about 1 millisecond, half millisecond. I'm saying symbol duration because symbol duration will vary based on various aspects, which we'll talk about. If you have 16 QAM, that means there are 16 states. And I mean, phase and modulation combination, there are 16 states. 4 here, 4 here. So you can transmit 16 kind of different data on this. That means you have 4 bit because 2 to the power 4 is equal to 16, and you can have 16 such states, right? 4 bits means 0, 0 से लेके FF तक ये जाएगा hexa में. So 16 type of information you can transmit. So number of bit you are able to transmit within the same symbol duration has doubled and so on. Now, if you recall my initial slide, which I said that 5G uses just here 16 QAM, 64 QAM and 256 QAM and QPSK. That means I'm saying that 5G uses this one, 64 and 256. ये वाला नहीं यूज करते, ये वाला नहीं यूज करते. What is the reason we are not using this 32 QAM and 128 QAM? Any guess from any of you? Why we are not using 32 QAM?
Odd number of symbols, sir.
Please again, come again, sir.
Odd number of symbols, odd bits.
Odd number of symbols. So इससे क्या गड़बड़ होगा?
Overlapping हो सकता है, sir.
Overlapping हो सकता है. Rajesh Rai ji has raised hand. Do you have any question, Rajesh ji?
सॉरी मैं पहले पूछ चुका हूं सर, इसलिए वो शायद ऑफ करना रह गया था. तो इट इज ओके सर. रिप्लाई टू दिस कुड बी पॉसिबली बिकॉज वी हैव normally 8 bits and so we have 4 bits combination. So the moment you go for 7 or 5, then it will be a waste of either a waste or maybe a shortage of some bit. So probably that's why we have to go in a multiple of 4 actually.
Sir, the constellation is not like square shape in this 32 QAM and 128 QAM. The constellation is not square shape.
Yeah. So basically, if I have to give a very broad answer, so suppose this is BTS and here is the user. if I am able to receive a signal which is modulated with 32 QAM, I'll be able to actually receive even the 64 QAM the way it is modulated. So there is no, benefit in using 32 QAM when I can actually receive 64 QAM at the same place at the same signal quality. So that's why we use these 64 and 256 and not this 32 and 128, because although we can use technically, but it's of no use. No benefit. I'll just take one call and hello. So may I call you later? I'm in a meeting. Okay.
So Ashokji, I have just one question on that.
Haji sir.
Just now you have said that with 32 QAM,
Yeah.
then 64 QAM, the same logic can be extended to the 256 QAM also. Then why we will use 64 QAM? Why not we will use 256 QAM only?
नहीं आप ये देखिए सर, यहाँ पे आपको फिगर देखने से पता चलेगा कि so the practically what has been found that for say for 128, so whatever signal level required to receive a 128 more or less same is equal with 256 QAM sir, and that is not the case with 64 and 256. That is not the case with 64 and 256. It is between 128 and 256 and 32 and 64. This is how is explained in various textbooks, sir.
Okay.
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 Thank you, sir. So in OFDM, the very broad and basic modulation, I'll not go much into detail, that as you know that the serial data is getting converted into parallel data because I have n number of subcarriers and data is modulated on those carriers. So we call it constellation. When we convert into this QAM, a constellation is made. So we map that QAM source onto the n orthogonal subcarriers. And after that, what we do is we do IFFT, inverse of fast Fourier transform. So basically what we are doing is we are combining all those subcarriers into a single type of carrier, summation of all n subcarriers onto the transmit side, and we do reverse onto the receiver side. So that is a basic diagram. I will share with you a detailed reading document on OFDM. That's a very big concept which you can go through in case you are interested. I'll give you a link where this is explained in a very beautiful way. For our class, let's move forward. So I think it's already 5. So let me stop here and I'll continue this session maybe tomorrow. Tomorrow, and then let us discuss if anything you want to discuss, and then close it for today and continue tomorrow. So any query or question today, or shall we kind of break for today's? Thank you, Praveen. Yes, sir.
Sanjay Kumar from Ranchi.
Sir, आप वीडियो खोलें सर.
Okay.
Right, sir. Yes, sir.
First flight था ना, तो जो उसमें दिखाए थे कि you had told that there are some 205 plus commercially
yes
commercial networks in all across the globe. Now I have a small query. How many standalone networks are commercially launched?
Sir, standalone as of today only 35 operators have done it, sir. So okay. This was 35 and rest are all NSA as of now.
35 commercial SA networks.
Commercial SA networks are already live, and this was confirmed by one of guy from Geo also today. We had that webinar in the morning, sir. Geo session, he himself told about 35, and that is also a figure. If you go to the GSA website, sir, they are tracking.
GSA.com.
GSA com.com. So
Yeah,
they are
yeah.
also they're giving a lot of data. So they also in some of their report they have talked about this, sir.
Right. Thank you.
Thank you, sir. Any more question from anyone?
No question,
Except
Ashokji, but just I want to say you are working very hard on this, so that's great to see.
Thank you, sir.
Yes, it
Thank
takes a
you
lot
for
of
this.
effort to explain. So great.
Since it is my third course, sir, so it has become easier a bit. First and second was tough because everything was new. So when I was preparing for certain topic based on release 15, release 16 came by 3GPP, so I had to read it again and include. So very dynamic. So now release 17 has come. Some aspect I have to include on this. Maybe going forward during other sessions, I'll try to give you some distinct aspect of release 17 and 18 also, sir.
Yeah, and WRC is also going to happen again. So
yeah,
after 19,
has
so that
also
is another. Yes.
Yeah, yeah. So if there is no more questions, let us close for today. So thank you so much, and let me inform you that while I was taking session, although it is recorded on the Teams platform, in addition, I have also made it live on a YouTube channel, which I had given link